Hello everyone. Tonight we'll be doing Module 3, Lesson 14, and we're going to strategize to solve multi-term problems. Multi-term means that we're going to have more than two terms or fractions to add together, and we're going to be thinking about the most efficient way to do that so we don't have to do a lot of extra work or end up with denominators that are huge. Let's take a look at 2/3 plus 1/5 plus 1/3 plus 1 4/5. This is a multi-term problem because I don't just have 2/3 plus 1/5, but I have 4 terms. So this could get really complicated if I just started multiplying numbers to get denominators. And actually, the way this problem comes out, when I look at it, I see that I don't even have to find a common denominator, because I've noticed that 2 of these fractions have 3 of the denominator, and 2 of the fractions have 5 as the denominator. Now, the associative property tells me that I don't have to keep them in this order to add. The numbers can be in any order when I add them, and I'm still going to get the same answer. So what I want to do is just switch these two fractions. So I'm going to have 2/3 plus 1/3 plus 1/5 plus 1 4/5. And I'm going to put parentheses around the numbers with similar denominators, and I can see that 2/3 plus 1 more third is going to be 3/3, which is another name for 1. And when I add 1/5 plus 1 4/5, 1 4/5 is only 1/5 less than 2, so I want to add that 1/5 in, then I'm going to have 2, and when I add them together, my total is going to be 3. Okay, that was pretty simple. When I looked at the problem in the beginning, it looked kind of complicated, but just by switching the place of those two numbers, it became a very simple problem. Now we're going to try a multi-term problem with subtraction. Now, there is no associative property of subtraction, but we have to remember that every subtraction problem is actually an addition problem backwards. In an addition problem, the sum, or the number that we get from adding, is the whole, and the add-ins, or the numbers we're adding together, are the parts. And the parts are the things that the associative property applies to. You can move the parts around in any order, and your whole is still going to be the same. Now, since subtraction is just addition backwards, you can move most of the parts around. You cannot move the whole around. It has to maintain its position at the front, at the beginning of your expression. It's anchored right there. But because it is the whole, all these other fractions are parts, and they can move around. The thing is, you have to remember to move the subtraction sign with them, because these are in effect negative numbers. That subtraction sign is telling me that it's a negative number. So the subtraction sign has to go with the number to the right of it, or we're changing the value of the number. So when I look at this expression, 5/8 minus 1/2 minus 7/8 minus 1 1/2, I am thinking it would be better to do this in a different order. I'm noticing once again that I have denominators that are similar. All 4 aren't similar, but there's only 2 denominators that I have to work with, so I can save myself the bother of finding a common denominator, for now at least. I may have to at the end, but for now I'm going to see if I can avoid that. I have to keep 5 and 7/8 at the beginning because that's the whole. It can't go anywhere. But I can move my negative 7/8 or subtract 7/8 up to the front. And then I can follow that with negative 1.5 or subtract 1.5, and then let subtract 1/2 move to the end. And when I do this, I'm going to take 5 and 7/8 minus 7/8, and that's easy. I can do that in my head. That's going to be 5. And then the next thing I want to do is subtract 1.5, and that's easy enough. 5 minus 1 is 4, and 1/2 less than 4 will be 3.5. And then I'm going to subtract my final half here. And of course, 3.5 minus 1/2 is going to be 3. So my final answer will be 3. Now that was a pretty complicated looking problem, but when I put a little thought into it and I looked carefully at the numbers I was dealing with, it turned out to be a very simple problem. The quiz you will take on the next slide is going to be 2 5/6 minus 1/3 plus 1/6, and you're going to find. On the next slide will be the quiz, and this is the problem you're going to solve. 2 5/6 minus 1/3 plus 1/6. And before we go to the quiz, I want you to think about these things. What is the whole in this problem? That's the thing that cannot be moved. Which of these numbers are the parts? Where do you see numbers that could help you solve this problem? Okay, good luck on the quiz. Okay, this is a slightly different kind of multi-term problem. We have 3 terms here, and the first thing I'm going to do is take a look at everything closely and see what I'm working with. And what I notice is I've got here 14/3, an improper fraction. I've got a blank in the middle. I've got 9/4, which is another improper fraction, and I've got 8 and 11/12 as my answer. Now, this is unusual because we have the blank in the middle now instead of on the right side of the equal sign. So when you look at this problem, it looks like it is an addition problem, but it's not. We know the whole. The whole is 8 and 11/12. This is actually a subtraction problem in disguise. So before I turn it into a subtraction problem, I'm going to also think about the numbers in my denominators. And I see that I've got some numbers that work together very well. I've got a 3 over here in 14/3, I've got a 4 over here, and I've got a 12. And I know if I can turn my thirds and my fourths into 12ths, which is easily done, then I will have the same denominator for all the numbers. And I also, before I do that though, I want to take out the whole numbers from these improper fractions, because I don't have to multiply 4 times 14. I need to multiply 4 times 3 to get the 12 I need for my denominator. But multiplying 4 times 14, that's a big number. It's likely I'm going to make a mistake, and then I'll have to add it on to another big number, and it increases the likelihood that I'm going to make a mistake. So I'm going to go ahead and turn my improper fractions into mixed numbers. So 3 will go into 14. Remember, this is actually a division problem, 14 divided by 3, and 3 will go in there 4 times, which makes 12. And I'll take 12 away, and I have 12 away from 14, and then I've got 2/3 left. So that is actually 4 2/3. And I'm adding to something a question mark. And I'm going to move over here to 9/4, and I am going to see how many times 4 will go into 9, and that is twice, 2 whole times, which is 8, and I'm going to subtract that 8 from the 9 up here in the numerator, and I've got 1/4, whoops, got to get the right tool on here, I've got 1/4 left over, and when I get that all finished, I'm going to have 8 and 11/12. Now, some of you who are nimble with numbers can easily do this in your head, but I am going to go ahead and turn this into the subtraction problem that it really is. And that means I'm going to have to move my whole here up to the front. 8 and 11/12. And I'm going to subtract my parts. And the first part is 4 2/3. I'm going to subtract the 2 1/4. And then this unknown part is going to be out here now, because that's what I'm trying to figure out. That's going to be the answer to my subtraction problem. So I'm going to go ahead and think about what 2/3 and 1/4 are in 12ths. And of course 2/3 times, I'm going to multiply by 4/4. Oops. And that is going to equal 8/12. So this is 4 8/12 minus 2 1/4, which will be multiplied by 3/3. And that's going to be 3/12. So I'm changing that into 2 3/12. And it equals our unknown portion. So now now that I've done that, I can see this is great. I've got 3/12, and I've got 8/12, and I've got 11/12. Well, 3/12 and 8/12 is 11/12, so I'm taking 11/12, subtracting 8/12 and 3/12. That's just going to be crossed off. Those things are going to cancel each other out. And then I'm left with 8 minus 4 minus 2. 8 minus 4 equals, whoops, I just gave myself away there. 8 minus 4 equals 6, and then I've got to take away this 2 over here. 6 minus 2 equals 4. And now I know that 4 is the number that belongs in that blank. Our next tricky problem is blank minus 15 minus 4.5 equals 7 3/5. This is another multi-term problem, and at first glance it looks like a subtraction problem because we see all these subtraction signs in it, obviously. But the thing is, I know the answer to my subtraction problem. That means that it's really not a subtraction problem. It's especially since this is the part that's missing. This is the whole. These are all the parts. The whole in a subtraction problem is that number that's up front. So this is an addition problem in disguise. And I'm going to show you a tape diagram to show you why. Here's my tape. And I know that I'm taking away 15. I know that's one of my parts. And I'm also taking away 4.5. That's one of my parts. And I'm also, the other part, the part that's left over after I take those away from the whole, is 7 3/5. The thing that I don't know is the whole, the number that I started out with. So now you can see that I have to add 15 plus 4.5 plus 7 3/5, and then I can find out what the whole is. So I'm going to rewrite it as an addition problem. 15 plus 4 plus 7, and I'm decomposing my numbers, so I can add all the whole numbers up and then deal with the fractions separately. Got 1/2 plus 3/5 down here at the end. So the 4 I'm adding in here, and the 1/2 I'm adding in here, and the 7 I'm adding in here. The 3/5 I'm going to add in here. That means that I can go ahead and do this part. 15 plus 4 is 19, and another 7 is 26. And now it is time to change my fractions into equivalent fractions with a common denominator, and the denominator I'm going to want to use is 10, so I'll multiply 1/2 times 5/5, and that is going to equal 5/10, of course, because 5 is half of 10, and I will multiply 3/5 times 3/3. Nope, sorry, that would be 2/2. And that's going to be 6/10. Oops, and I'm running out of space. So I've got 26 plus 5/10 plus 6/10. And of course 5/10 plus 6/10 is 11/10, so that's going to give me one more whole to make 27, and I'll have 1/10 left over. So 27 and 1/10 minus 15 minus 4.5 equals 7 3/5. Okay, this is the problem that's going to be on the quiz on the next slide. So I want you to take a good look at it and think about what really is the whole here. This is another one of those where we've got the blank kind of in the middle of the problem instead of at either end. So what is the whole and what are the parts here? This is kind of a tricky one. So I want you to think carefully about that. Maybe draw a tape diagram to help you with it, and then go ahead and take the quiz. Good luck, and I will see you in school tomorrow.